on specific highway corridors and build from there.
Precisely. Turn the impossible into manageable, commercially viable chunks. Beyond the tech, there's a whole regulatory and legal maze. In the U.S., it's messy. A patchwork of different state laws. NHTSA, the federal agency, gives guidance and collects crash data through its standing general order, but there isn't one clear federal framework for deploying AVs yet.
Is it clearer elsewhere?
Europe. The EU is trying for a more unified approach, aiming for common rules. They already have a process for type-approving Level 4 systems, kind of like certifying a new car model.
What are the big sticking points for regulators everywhere?
Liability is massive. Who pays if an AV crashes? The maker, software supplier, owner, sensor company. It's murky and high risk. Cybersecurity is another huge one. These cars are connected computers, vulnerable to hacking. And data privacy, they collect so much video, location data. Who controls it? And ultimately, public safety and trust. High-profile crashes really hurt public confidence. Regulators need solid proof of safety, transparent reporting. Gaining and keeping that trust is absolutely vital.
And beyond laws and tech, there are the ethical questions. People always bring up the trolley problem.
Yeah, the trolley problem. It's mostly a distraction, honestly. Real-world driving isn't usually a simple binary choice of who to hit. AV behavior comes from its training data, its programming for safety, not some predefined moral code for impossible choices.
So what are the real ethical issues developers face?
It's more about the real-world ethical frameworks baked into the design. Things like algorithmic bias. If the AI isn't trained on diverse data, could it be worse at detecting pedestrians with darker skin? That's a real concern.
Why?
Accountability, clear lines of responsibility when things go wrong. Privacy, like we mentioned, are these cars mobile surveillance? And value alignment, how do you define good driving? Follow the speed limit rigidly, or sometimes exceed it slightly to merge safely? These are tough design choices.
And public trust is tied into this, right? People are still wary.
Very wary. Surveys show a lot of skepticism. Maybe 60–70% of people say they wouldn't be comfortable riding in a driverless car yet. Worries about safety, malfunctions, hacking. It can become a vicious cycle. Low trust means slow rollout, less data, slower improvement, maybe more incidents, which erodes trust further. Or hopefully a virtuous cycle. Proven safety builds trust, allows more deployment, generates more data, leads to faster improvement, building even more trust.
The ripple effects just keep spreading. What about the economy, jobs, or cities?
Yeah, the economic shockwaves could be enormous. The most obvious is labor market disruption. Millions of driving jobs in the U.S. alone. Truckers, taxi drivers, delivery drivers are potentially at risk, maybe over 4 million.
That's a huge number.
It is. And it hits certain groups, harder workers without college degrees, men, some minorities are overrepresented in driving jobs. We'll need massive efforts in retraining for new roles. AV technicians, remote monitors, AI specialists.
And cities, you mentioned parking.
Urban transformation. Think about it. Most cars sit parked 95% of the time. AVs, especially shared ones, could drastically reduce the need for parking. All that land currently used for parking garages and street spots in cities, it could be freed up for parks, housing, bike lanes, wider sidewalks, a chance to make cities more people-focused.
But could it also lead to more sprawl if commuting becomes easy?
That's the potential downside. If you can work or sleep while your AV drives you 2 hours, maybe people move further out. So it could reinforce density or enable sprawl. It also triggers this great unbundling of real estate value from parking and immediate transit access. Property values could shift dramatically.
And how we actually get around the future of mobility.
Big shifts there too. A move towards transport as a service, TaaS. Why own a car, especially in a city, if summoning a cheap robotaxi is easier and cheaper?
That's a threat to car companies selling cars.
Existential threat for traditional models. They need to become mobility service providers. Public transport also faces challenges. Competition from robotaxis could hurt ridership. But maybe AVs help, providing first-last-mile connections via autonomous shuttles. A huge positive is enhanced mobility and social equity, giving independence to seniors, people with disabilities, others who can't drive, better access to jobs, healthcare.
So the future is this integrated network.
Exactly. And the big strategic battle will be over controlling the platform, the mobility as a service, MaaS app, or system that connects all these options and owns the customer relationship.
Okay. It's clear this is so much more than just cars that drive themselves. It's a marathon, a massive transformation touching almost everything. We've seen that core tension, vision only versus multi-sensor, leading to maybe 2 paths. Evolution for the cars we buy, revolution for commercial services like taxis and trucking. So thinking about all this, the huge societal changes coming from jobs to cities, It leaves us with a question for you, our listener. What kind of future do you actually want to see emerge from this? And how do we make sure this powerful technology benefits everyone, not just a few? Something to think about. Thank you for joining us on this deep dive. We'll catch you next time.